Okay, so I'm going to do a few flip lessons on different science concepts. So through this process, we'll be going over weather, heat transfer, and ecosystem. So we're starting with weather here. So weather is the condition of the atmosphere at a certain time and place. Measuring weather conditions help meteorologists predict future weather. So this is the day-to-day changes in the atmosphere. That's when we get our weather forecast. Is it sunny, raining, snowing? Climate is the average weather conditions of an area over a period of time. So when I look at this picture over here, I'm really getting the feel of climate. Does it have seasons? Is it raining? You can tell by the greenery on the trees and in the grass, the different types of clouds in this picture, besides this more desert and dry climate on this side. So it's the conditions or weather of an area over a period of time. They have this type of weather more often. Next, we have weather instruments. Thermometers measure temperature or how warm or cool the air is. And we have a picture here of a thermometer. A rain gauge measures precipitation. Remember, precipitation is rain, sleet, snow, hail. And this right here is an example of a rain gauge. Wind vane and anemometer. A wind vane measures wind direction, while an anemometer measures wind speed. Sometimes you see these things together. This one's going with wind direction, north, south, east, or west, and this is measuring speed. So what happens is that in these half-like circles, these cups, it catches the wind and spins it, and it will actually measure how fast it is spinning to get how fast the wind is blowing. A barometer measures air pressure. It's the weight of the air. This can also tell us if we're going to have good or fair weather or stormy weather. So if you look here, we have a barometer. And this air pressure, the higher the air pressure, the better the weather we're having. So 31 or above, we will have sunny and nice weather. Anything below it, we get more cloudy. And the lower we go past 29, we get more storms. And a hygrometer measures the humidity or water vapor in the air. So here it tells us on the hygrometer the humidity, how much moisture or water vapor is in the air. The higher the water vapor, the more likely we have for storms. Clouds also can help us predict upcoming weather patterns and events. Clouds are masses of teeny water droplets. So if we think back to the water cycle, after evaporation, we have condensation. So clouds form when water vapor in the air cools and condenses around teeny pieces of dust in the air. When this water vapor collects to that dust, you start forming clouds. This is also real-world example of convection. So when that water vapor gets into the atmosphere, it starts cooling down, it condenses and forms that cloud. There's different types of cloud, and it's used to describe the weather and predict upcoming weather. Stratus clouds, you see them down here. They are low-level clouds. They're like sheets of gray. They bring rain. Usually when you have that, you have like rain or drizzle all day. Cumulus clouds are also lower clouds, and they are puffy, but it is also sunny weather clouds, very fair-like. Cumulonimbus are large thunderhead clouds. They bring thunderstorms. So this huge cloud that grows up through these levels is a cumulonimbus cloud. It has that anvil shape where it's flat and gets skinny towards the middle and then kind of flattens out at the top. Thunderstorms, severe weather. Cirrus clouds up here are thin and wispy clouds, and they're associated with fair weather and approaching rain. So typically we see cirrus clouds on a sunny day, but it usually means within 24 hours the weather will change and we'll have rain in the forecast. Air masses are a large body of air with about the same temperature and humidity or moisture throughout. So air masses have the same temperature and humidity within it. So here you can see on the globe, this is over the United States. Over towards the equator, we have warm air masses, and that makes sense. It's more tropical. It's getting more direct sunlight, so it's warmer there. So the air there is going to be warmer. Over here we have more moderate. It's colder air mass, but not as cold as up here. So this is a light temperature right here in the middle. And then up here you have your polar air mass where it's much colder. Here of the United States, you can see an example of the jet stream and how warm air masses are coming from the south and cold is coming from the north. Fronts are where two air masses meet. So when you have that cold and warm air mass move together, where they meet, you get different kinds of fronts. So a cold front is a cold air mass bumps against a warm air mass, and it brings strong storms like thunderstorms or snowstorms and causes a drop in temperature. It makes sense. Cold front, drop in temperature because it's going to be cold. Usually when you see a cold front, it has on a weather map, it has the line with the triangle, so it is more pointed. And the way they are pointing is the direction it is moving. So you see cold front moving across the United States here. A warm front is a warm air mass meets a colder air mass and rises over it. Often brings rain, stratus cloud, and an increase in temperature. So here's the difference here. Warm air, you're going to have increased temperatures. Makes sense. Warm air, it's going to warm up. But here you kind of have your stratus clouds and just like rain where it's like a constant drizzle. When a cold front, you have that sudden storm. Very difference between like a rainy day and like a severe storm and severe weather. So a warm front has usually red, but it has the more like half circles over it. And again, whatever direction it is, the half circles are facing is the direction it's going. So you can see a warm front moving towards the north here and here. And a stationary front are where two air masses meet and stop moving. It brings clouds and precipitation that often lasts several days. So down here you can see these different fronts bringing warm air towards the front and cold air. So here's where they're colliding. We're getting different weather moving through. Here, cold fronts moving from the north down through the United States, so the temperatures are colder. We might have snow within here or rain, depending on the type of year. So these stationary fronts, it causes this precipitation over a few days. So in this example over here, you can see where there's a stationary front over Texas. So it's probably going to be raining there for quite a few days. Next is something that we skipped over the first round, so I really want to make sure that I hit on this. Like what are our prevailing winds? The uneven heating of Earth's surface causes wind. Wind is just moving air. The greater the difference in temperature and pressure, the more wind there is. So when there's a pickup in wind speeds, it's because of that change in temperature and pressure. So if we look at here, in the center we have trade winds. They kind of blow towards the equator. And then you have your westerlies. Winds are named from the direction they blow. So westerlies move from west to east. While in the north, you have north and south, you have polar easterlies. They have this polar wind, but they move from east to west. Now you have to remember, these winds blow different ways because, again, the world is round. It's a sphere. But I included this picture because it actually includes the tilt of the world. So the sun is is warming the earth more directly at the equator. So your trade winds are blowing into the equator. And actually right here where the doldrums are, this is where when the trade winds move together and actually blow wind straight up. This is more of a warmer area. It's typically called the trade winds because in early exploration, this is how the explorers traveled using the wind and ocean currents because their boats did not have engines. Westerlies are what are responsible for the winds that affect the United States weather, and they blow from west to east. You can see over the United States right here. And this is the main one you'll probably have questions on because it's prevailing westerlies. They affect our weather. And then the easterlies are in your poles. And they are polar easterlies. Easy to remember because they include polar and it has those Arctic winds that moves from east to west. The jet stream is an air current that flows from west to east across the United States. When the jet stream dips south, that's down south, it brings cold Arctic air down into the United States, just like in the picture below. When the jet stream bends north, it carries warm air from the south, and it kind of warms up. So that's how we get that the different temperatures, and we'll have cold fronts and warm fronts that all come in together with that because the jet stream's really is significant in that area. And then the Gulf Stream is a warm ocean current. It's in the ocean off the Atlantic coast that carries warm waters out across the Atlantic Ocean and towards the north. It keeps weather along the coast mild. When I think of mild, it's more warm. Without this ocean current off of North Carolina's coast, would be much colder here. So you actually can see in this infrared picture, you can see where this warm, there's Florida here, and then North Carolina's about here. It brings this warm tropical water up towards the north. And actually in this picture, it kind of zooms out. Here is our Arctic, where Greenland is. There's Florida here in the United States. And this is actually where part of Europe and the United Kingdom are, in England. So it actually brings this warm water out across here. And it's said that if we did not have the Gulf Stream, that this area would actually be covered in ice and frozen. So having warm tropical water really affects the climate of the land that it is near. And last but not least, El Nino. El Nino is the unusual warming of surface water in the Pacific Ocean. So over here we are on the East Coast, but if we go to the West Coast, El Nino is when there's warming of this water, and because just like with the Gulf Stream, if the water warms, it's going to affect the climate and weather across here. El Ninos and La Ninas can last anywhere from 9 to 12 months, and so it can affect the weather over a whole year. So usually within the because the water is above average temperature, it makes the warming of the temperatures above average. It's wetter in the Gulf in Florida, and it's much drier in the Northwest as this comes across the United States. Now, La Nina is the opposite. It's the unusual cooling of the surface water in the Pacific. So when this water cools down, again, it's going to affect the climate of the United States. So there's below average temperatures, which makes sense if the water is cooler than average. So it's going to affect the average temperatures here. It's going to lower them. So below average temperatures, it's actually warmer in the southeast near us because of the tropics moving through here. And then it's cooler in the northwest as it moves across the United States. So hopefully this helps give you some clarity in our weather content. Rewatch as you need to, and take notes. There'll be questions popping up later on.